Hi! Today me, Pimvalan, Peemai, Chatchawat, Tham and Thammathorn are going to be talking about the edible water bottle, which is made through the process of spherification. We tackle 3 questions, which is what is spherification, what causes spherification, and how the edible water bottle can be used in the real world and how it can improve in the real world. And we're also going to be showing you the process to make these edible water bottles, and we're also going to be showing you the ingredients that we use for these edible water bottles. Let's start with the first question. What is spherification?
Spherification is a process in which we employ sodium alginate and calcium carbonate to shape a liquid into a sphere. The texture is like a resemble roll. Spherifications are useful in many ways. It can be useful in saving our planet because it is alternative to cups and bottle that is waste-free and environmentally friendly. Nowadays, chefs together with many restaurants adapt this technique to fine dining, which is result as a popping boba. This can be added into beverages or food for addition of texture and flavors, such as green apple or tea.
Now, what causes spherification?
Hi, so I'll be talking about what causes esophagification. Esophagification relies on the ability of calcium to cause alginate to gel. Excess calcium can prevent hydration and cause a liquid to gel prematurely. For direct esophagification, calcium is often naturally present in the flavorful liquids. So the solution is to add sequestrant. Well, now you may be wondering, what is the molecular structure of the spherification? Well, here I have a photo for you. What you have just seen, guys, is this structure right here, which is the structure of calcium alginate, which is our end product. Our end product is formed by calcium lactate and sodium alginate, which are the 2 chemicals we use. We mix this one into one of the liquids and this into the other, which depends on whether you're doing spherification or reverse spherification. In this case, we're doing reverse spherification, which means we add sodium alginate into the pungent liquid, the flavorful liquid inside the ball, and calcium lactate into water outside the ball. After they mix and then they form a layer outside, it's a layer of calcium alginate. Calcium alginate is this gooey sticky substance that's like quite firm when you form it into a sphere, but it doesn't keep water inside and outside separated, which means the water inside and outside can dilute. So when making this, you would have to store these balls inside a solution of the same type of liquid, and it can be kept in there for quite a long time.
And how the edible water bottle could be used in the real world.
How can the edible water bottle make an impact in the real world? The edible water bottle is a blob-like water container which is made from algae gel. The biodegradable packaging was created by Skipping Rock's lab in an attempt to make a more environmentally friendly alternative to single-serving plastic bottles. It is biodegradable and can actually be eaten. Plastics and the byproducts are littering our oceans, cities, and waterways and contributing with health problems in humans and animals. The impact of this new invention could help reduce the amount of plastic waste from water bottles, which has been a problem for many years.
I will also show you the process that we took in making these edible water bottles and the ingredients that we used, as well as its ratios. So we used calcium lactate and sodium alginate, as Leong and Thammathorn has explained. These will mix with water. We'll mix 5 grams of calcium lactate into 4 cups of water and 1 gram of sodium alginate into a cup of water. The sodium alginate mixture is a little bit hard to mix because it doesn't really dissolve that well in water, as it is an algae extract and is kind of like jello. So you have to mix it pretty well and let it sit for 15 minutes to get rid of all the bubbles to make the edible water bottle that you're going to make clear and nice. And after those 15 minutes are over, we would use a rounded spoon, a spoon with a rounded bottom, to scoop up the sodium alginate mixture and put it into the calcium lactate mixture. It would start forming a covering or a thin film forming right away over the sodium alginate mixture, but leave it in there for about 3 minutes to let it fully form into a ball. And our experiment is a little bit weird because it didn't form a complete ball. It was strands of like gelatinous water, and it's a little bit weird, but I guess that it was because we used a weird soup spoon. I guess if you would freeze the sodium alginate mixture and then put it into the calcium lactate mixture, it would also work as well to make it form a complete and rounded ball. Nevertheless, we did get a little bit of the round ball effect of the edible water bottle. Thank you for watching the video, and bye.